Okay, I'm going to present a recent development. We developed a rapid scanning system to quickly evaluate the concrete bridge deck. So I really want to acknowledge my graduate student, Hong Bin Sun. He did most of the work. So we know our bridge, okay, concrete bridge are old, and the bridge deck is the part that experience most of the deterioration. And if those defects are undetected and unrepaired, it's going to cause the safety issue. But how do our engineer and Department of Transportation and state duty to do in the practice, how do we evaluate the concrete bridge deck? Okay, so now let me show you a short video. Come on. Why? It always work. Always work. Except when you need it. Cannot play media. Well, let me see if I can. Okay, let me see other videos. That's the important part. Okay, but anyway, so currently people use the chain drag. They just use the chain, sweep the surface, and then see what's the, if they can hear a hollow sound, that means there's a problem. And then they use the chalk, use the paint to mark on the surface, and then need to later come back to do the map. Okay, everything's a menu. So, I hope the next video will work. So the challenge is, it really depends on the listening. Okay, if there's a traffic noise, and everybody may make a different decision. And so, because it's subjective, and so we don't save any data. If the person make a mistake, and there's no way to check. And also the mark and the map defects, they're slow. So the solution we propose is, we try to use microphones to replace the human ear. And so we can use some, human has only 2 ears, but we can have many microphones. And we do not need to guess yes or no. And we can use the algorithm to automatically detect the defects. You get a clear result. And with the positioning system, we can immediately generate a map. I really hope the next video will work. Okay, so this is what our system looks like. So this is the RTK GPS with the centimeter level accuracy, give the real-time position. And there's 12, actually this one maybe 8 microphones, and that's actually the most important part to success. So those are the metal balls. They're not the regular chains, and I really hope this one will work. Okay. Okay. If not, let me stop, restart. Is that because of this deep here? Can Now let's look at the system setup procedures. First, we configure the base antenna of the RTK GPS. You may use a laptop computer, or a tablet, or even your cell phone to configure the unit. Next, we set the rover antenna to reach RTK fixed. At this time, you can get a centimeter level of accuracy. Make sure you have an open sky for better performance. Third, expand the testing frame to get at least 6 feet lateral coverage with 12 MEMS microphones. Now we are ready to go. The scanning system has a lateral resolution of 6 inch In the scanning direction, we have a very high resolution, typically less than 1 inch. To test a 300 feet long bridge, we need 2 scans for each lane, and each scan only takes about 1 minute. After the test, we can immediately process the data to generate a map image of the bridge deck, then use the damage detection algorithm to identify the defects. Okay, so that's the overall procedure for the test. So this is just one example. We test a 3 feet long bridge. It took less than 5 minutes to scan each lane. And actually this yellow rectangles mark the manual change reg check. So we get really good agreement. And this is also another very interesting video I'd like to show you. That's the traditional way doing change reg. And we were doing the first pass, first running. You notice how close that person to the marker. Okay, that's our very last pass. See, that person maybe only moved 5 feet. You really think you're probably close to retire? Okay, so this is a bridge we tested last month along I-80 intersection. So that's a very long intersection. That's almost a 2,000 feet long bridge. And I think so the entire scanning time was less than 30 minutes. So we can generate a map of this curved bridge. So for more details, technical details, tomorrow you're welcome to come to our session and in the room 420, and my student going to give a presentation. Thank you.
Okay, thank you very much. Maybe in 2 years' time, will you bring the vehicle with you, and then everybody can maybe try outside, and there's so much construction here at Stanford campus at the moment, they will possibly appreciate regarding the condition of their streets. Okay, thank you.